fellow physics students. We're going to continue to talk about the concepts in Chapter 2 now as we move past the concepts of displacement and distance, speed and velocity, average versus instantaneous. What we want to do now is talk a little bit about the concept of acceleration. Acceleration can be one of the trickier concepts here because, like speed and velocity, it is a rate, but it's a change in a rate, which makes it a little trickier. So let's get a formal definition down here. When we think about acceleration, what we want to recognize is that it is a rate. But specifically, it's a rate of change. And when we go to define this, again, like the other things we've talked about, it is a measure. It's something that we can measure either qualitatively or quantitatively. But in this case, it's a measure of the change in velocity of an object over time. So, just taking what we just described there as it being a measure of a change in velocity, first of all, we want to say that acceleration, we're going to use the letter A for. And I'm going to go ahead and talk about average acceleration. So the average acceleration of an object moving left or right on a number line in one dimension is going to be a change in its average velocity over time. So again, in this instance, we have A for acceleration, V for velocity, and T for time. All right, let's talk about what that really means. All right, are we talking about something that's a vector? Are we talking about something that's a scalar? Well, what we know is that velocity is a vector. So to indicate that its velocity was changing would mean that it's either changing in magnitude, that is its speed is changing, or it's changing in direction. That means it's not speeding up or slowing down, but it's going to go in a different direction. If it was going to the right, now it's going to go to the left. If it was going to the left, now it's going to the right. So because it indicates a change in magnitude or a change in direction, then I think we can pretty confidently say that acceleration is a vector quantity. So what does it mean to accelerate? Well, we just said it. It means the object is going to speed up, slow down, or change direction. Any of those would be considered an acceleration. Now, this is sometimes a little tricky for people because we have in our car a pedal called an accelerator. And when we push it, we go faster. And yes, speeding up does mean acceleration. But technically that other pedal in your car is also an accelerator. When you push your brake, you slow down, which is an acceleration. It's a change in velocity because you're not going at the same speed anymore. So if your velocity decreases, you slow down, you just accelerated. And technically you have one more accelerator in your car, your steering wheel. If you turn your steering wheel, you're going to change direction. So any one of those three things will be an acceleration: speeding up, slowing down, change direction. So that means your gas pedal, your brake, and your steering wheel are all accelerators. Now, let's talk a little bit about this relationship between velocity and acceleration in greater detail. What does it mean for an object to have a constant velocity? It means it's not speeding up, it's not slowing down, and because we specifically are talking about velocity here, it means it's not changing direction. Now, if it's at a constant speed, that'd be something different. Speed is a scalar quantity. It doesn't have a direction. So if it said it was moving at a constant speed, that would just mean not speeding up, not slowing down, but it wouldn't necessarily include a change in direction. Because it says velocity, that definition is very specific. That means that you put on your cruise control, that's not going to change your speed, but it also means you can't steer. It means you got to keep going in a straight line. So, if something is moving at a constant velocity, it means that the velocity is constant and the acceleration is 0. What does it mean if the object increases in velocity? If the velocity increases, that means it's speeding up. That means we have acceleration. But is it positive or negative? Well, don't forget, in physics, positive and negative means direction. So be really careful with that. A lot of times people will say, oh, it's speeding up. That means positive acceleration. Well, think about that. Could something have a negative acceleration and be speeding up to the left? Because the negative part means to the left. What about a decrease in velocity? Well, that's also acceleration. Your acceleration is not 0 in either one of these cases. What about an object at rest? Now your velocity is 0, which means your acceleration is also going to be 0. So, think about this question again. If an object slows down, is its velocity a positive or negative value? Is its acceleration a positive or negative value? This is one of the trickiest things in physics. A lot of times people get really confused here. Does speeding up or slowing down necessarily mean positive velocity or negative velocity? Does it necessarily mean positive acceleration or negative acceleration? Don't fall into our trap. Here's how you know if something is speeding up or slowing down. You need to think about the sign of both the velocity and the acceleration. I'm going to star this slide because this is where most of our students are going to make a mistake. Assuming that positive or negative means something other than direction. It doesn't. To a physicist, positive and negative are direction. So if something is already moving to the right, and then it starts accelerating to the right, it's going to speed up. A good way to think about this is to think about the relationship between force and acceleration. Things don't just speed up for no reason. Something must be pushing or pulling on it to make it speed up. So imagine that you were running to the right and somebody shoved you to the right. You would probably speed up. So accelerations usually go with forces. So that's what's happening here. So if it makes it easier for you to think of acceleration in terms of force here, by all means. So if something's moving to the right, and then it accelerates to the right, somebody shoves it to the right, it's going to speed up. But just as validly, if something was already moving to the left, and somebody shoved it to the left, then it would also speed up. Here's a case where something has a negative acceleration but is speeding up. Sounds like a multiple choice question on a test to me. Can something have a negative acceleration and still speed up? The answer is yes, as long as it was already moving in a negative direction. So what does it mean to slow down? Well, notice, here, when something speeds up, it's because the velocity and the acceleration have the same sign in both cases. When will things slow down? Well, objects will slow down when their signs are opposite. If something is moving to the right, and then somebody shoves you to the left in the opposite direction you're going, you're going to slow down. Or if you were already moving to the left and somebody shoves you to the right, you're also going to slow down. So things are going to slow down when their signs are opposites. What will it take for something to keep moving at a constant velocity? Well, regardless of whether or not the object is moving to the left or the right, if there's no shove, if no one accelerates it, if no one gives it any push or pull in any direction, it's going to keep going in whatever direction it's going. This is called a constant velocity. It's neither speeding up, slowing down, or changing direction. And a special instance of this is if something was already at rest, so it had no velocity to start with, and then you start pushing, either to the right or to the left, or pulling, then it's going to increase its speed because it has no choice. It can't go to a lower magnitude speed than 0. And then finally, if it has no velocity initially and no one's pushing or pulling on it, well, that thing's not going to move. It's going to remain at rest. So the tricky part here is to make sure that you understand that when it comes to acceleration, it's not possible to determine whether or not something is speeding up or slowing down by viewing only the acceleration. You need to know which direction it was moving, if any, at the time that that shove, that push or pull occurred. So, let's take a look at this graph. This is a velocity time graph, not a position time graph. That means what we're looking at here is a graph of how fast it's moving at a certain amount of time. And as it turns out, when you have a velocity versus time graph, the slope of the graph tells you the acceleration. So here we can see that the velocity is increasing. And then right in here, it's still increasing, but it's increasing at a lower rate because the slope isn't nearly as steep. Here we can see the slope is practically nothing, which means the velocity back at this time and the velocity at this time hasn't really changed. The velocity has remained pretty stable. It's not speeding up or slowing down. We have a constant velocity. If we have a constant velocity, that means we don't have any acceleration. We don't have a change in the velocity. Here we can see the velocity is pretty steep, but now it's a negative slope. Whereas here, this was a very steep positive slope, a less steep positive slope. Here we have a negative slope. Don't forget, positive and negatives in physics mean direction. So think of it as the positive or negative slope. Think of it as the direction that this thing is being shoved or pushed or pulled. So we can see that it was moving to the right here and was being shoved to the right. So yeah, of course it's getting faster. And here we can see it's still moving to the right and being shoved to the right, but not as vigorously. So it's still speeding up, but not as much. Here we can see that it's still moving to the right, but at a constant velocity. Don't get this confused here at point B with the idea that it's at rest. This isn't a position time graph. If it was a position time graph where the slope is velocity versus, where the slope of a position time graph is velocity, then no slope would mean no velocity, not moving. But on a velocity time graph where the slope is acceleration, it actually means that it's no change in velocity, which means it's continuing to move to the right, but it's neither speeding up or slowing down. The negative slope at point C tells us that the shove is now to the left, even though the object is moving to the right. In case you're confused, how do we know that the object is moving to the right? Well, we kind of think of it this way. This is the axis that tells us velocity. These numbers here all have to be positive. Positive 1, positive 2, positive 3, and this is probably 0. These have to be negative. Negative 1, negative 2, negative 3, and so on and so forth. So everything in this first quadrant has to be a positive number, and positive numbers mean moving to the right. So that means we have an increasing velocity at point A, we have a constant velocity at point B, and we have a decreasing velocity at point C. That means we have a positive acceleration and a positive velocity at point A. We have no acceleration and a positive velocity at point B, and we have a negative acceleration and a positive velocity at point C. That means that we can clearly see that positive and positive